Students, welcome back to the next part of the lecture, the second part of the lecture. So, we have been talking about artificial neural network. I gave you some idea about perception and even how the model is developed. So, now let us talk about how the errors are calculated. As you know, most of the learning methods, they basically involve an iterative procedure for minimization of the error, right. We have talked about it, iterative procedure, back propagation, all kinds of things, right. And what's important aspect is to minimize the error. So, therefore, here this is done in a sequence of step. So, first let us go back the board and let us talk about the error. Let us say x is your input, y is your output, right, that is what the normal is. And in a machine learning, because since you are using data, you have set of inputs like xn and with certain target values, right, corresponding to each value of x. That is what is the supervised learning is. Okay. For x1 you have a t1, x2 you have a t2, x3 you have a t3, goes on till n. So, what is the error function in ANN? This is like this is called sum of square error. EW is equal to half summation from n1 to capital N, then y xn w minus tn whole square. Okay. You can see this is a mod. So, that is difference between the output and the target function, correct. That is what you are calculating for each step and you are summing it over, correct. That is what is the error function is used in the machine learning. Now, the question is, as we said, so we use lot of iterative methods to reduce the error. How we reduce the error? So, here what happened, we have used several steps and we need to distinguish what actually happened. In the first step, step 1, what do you do? In the first stage, the derivatives of the error functions, is basically with respect to the weights. Remember, weights are the one which has to be optimized, must be evaluated. First step is that. So, you have to take derivatives of this error function with respect to the weights. This you see the error function is basically as a function of weight, right. Here also it is there weight. So, once you do that, second stage, what is that you do the second stage? The derivatives are then used to compute the adjustment. These derivatives are then used to compute adjustments to be made on weights. So, this can be done even in every layer when you are doing the calculation. This can be done. After each layer you can calculate the error and then take the derivative of the error with respect to the weights and go back to this. This can be iterative process, iteratively done. Okay. These two can be done iteratively. That is the idea. So, with this idea we can calculate error, right, very easily. So, let us take a network, single layer network. If I take a single layer, so I will just erase some part of it. Let us take a single layer network and show what can happen. So, if I take a single layer network, single layer means what? One hidden layer. You have input and output and one hidden layer, that is what a single layer network is. If I take a single layer network and sigmoidal type is exactly what I give. Sigmoidal is this function fz is 1 by 1 plus exponents minus z. That is what the sigmoidal function is, a step function. Together with the sum of square errors, that is what it is, single layer sigmoidal function as activation functions together is the sum of square error. Remember, errors can be other type also, but this is the most widely used way of calculation error, that is called square sum error, sum of square error. So, now the function comprised of a sum of terms and one of each of the data points in the target, right. So, EW is what? It is nothing but summation n 1 to n, okay, small EW, that is the error in each step, right. So, and if we consider a linear model, let us consider a linear model. You can consider non-linear also, but for the sake of simplicity we consider a linear model. Let us consider, oh, so I forgot to write the word consider. Let us consider a linear model. If you consider linear model, what can happen? So, if you consider linear model, the output is nothing but, let us say output is yk, it is a linear combination of this. Each step output is that, a linear combination of that. That is what it is, it is a linear model, you are multiplying with the weights. So, therefore, your error function for this, remember this is for each step we are doing, right. You have hidden single layer means what? You have input, one hidden layer and output. So, these are all connected. This is your hidden. So, that means what? This is single layer and we are also assuming a linear model. So, therefore, error function will look like this. Am I correct? Ynk is the error. It is a function of, it basically depends on yk, which depends on xn obviously, and w. That is very clear, because your output depends on y, you have x and w. So, error will also depends on w and x, but remember x is your input. If I take the first derivative of error en, okay, ew, that is what it is, that I am writing in terms of n with respect to w weight ij, that will be equal to y nj minus t nj into x n I, sorry n, yeah, n I, okay. So, that is what will be your derivative of your error respect to the weights. This can be proved actually, I am not proving it, but this can be proved, right. So, what you see here? What you see here, that remember this is for each step, right. N stands for 1, 2, 3, 4, 5, 6 to n, right, and W stands for weights. So, you have basically two parts in the error. One part is this, another part is this. So, what is this part? This part is basically output end of the link, is due to output end link. That means what? At the end of this, so output end is here, that is what is this part is due to, the error due to that, in form getting difference between these two values. T is the target value, remember, okay, you already talked about it. Target means for every xi there is a ti, right, or every xn there is a tn, that is what. So, that is the T is the target. Since the supervised learning, that it will be there. And what about this? This is the input end of the link. This is due to input end. If I have error in the input then this problem will happen. So, therefore, in a nutshell, what I showed you is that the error is basically depends on both the output end link and the input end link, and you have to, then that is why you have to do this iteratively many times to take care of the weights, specific weights to be done, and this is what is done in backpropagation network to minimize the error. Now, why the square error? Because square error, we remember that in a statistics this difference is what is your standard deviation. If you take a square root, that gives you the standard deviation, that is why this is used, and that talks about the takes care of the every kind of error possible in the artificial neural network. Hope you could learn more on that, but that is the mathematical way of understanding how error can be tuned. So, I will go to now the next part of these things, that is called KNN. K stands for anything k, we will talk about what is k, and N stands for nearest neighbor. So, what is it? First you have to learn understand the difference again between eager learners and the lazy learners. Okay? We talked again and again. Eager learners are machine learning algorithms. They first build a model from the training data set and then make the prediction on the future data sets. So, therefore, they spend more time during the training process, and because they have to generalize it during the training process, learn the weights, but they require less time for predictions. So, eager learners develop a classification model based on a training data sets after receiving all the data. On the other, lazy learners, they sometimes are called also instance based learners. Instance based learners do not create any model immediately from training data, they rather memorize the training data. This is where the lazy words comes into picture. They memorize the training data, and each time there is a need to predict, they will search the nearest neighbor from the whole training data. That is why this KNN things come. What is KNN? Nearest neighbor. Actually, they search the nearest neighbor data and then make the prediction. That is why they are slow in prediction, and it takes less time in training, but there are more time it takes for predictions. Okay, that is the difference between that. KNN comes on the lazy learners. Okay, remember, ANN comes under eager learners. They are developing first the model, learning it, and then predicting it. So, KNN become very basic. This is a very basic classification algorithm, but it is used in material science a lot, and it is a supervised machine learning obviously, and it is intensively used in pattern recognitions, data mining, intuition detections. Let us take this plot on a graph. We may be able to look at some clusters, right. See, there is a red clusters category 1, there is a blue clusters called category 2. Now, if I have an unclassified point like this one, which is new data point shown as like this, correct, we can assign which one shall I assign? Shall I assign to blue because its color is blue, or shall I assign to red? That is the question you ask, right. This means the point is, so now how it is to be done? So, the way it is done is that by observing which group its nearest neighbors belong to. It has nearest neighbors and which group it belongs to, right, nearest neighbors. This means the point is close to the cluster points classified as a red has a higher probability of getting classified as a red. So, KNN algorithm works by finding the k nearest neighbors or number of nearest. K means k can be anything 1, 2, 3, 4, 5, 6, 7, 8 to a given data points based on a distance matrix, remember, because distance matrix is what it can by which it calculate the nearest neighbors, and this distance matrix can be anything, but we normally take a distance in Euclidean space, and distance in Euclidean space is nothing but this x1 minus x2 square plus its coordinate geometry. That is what is the distance in Euclidean space, right. And so, this is how it calculate the distance, and then find out nearest neighbors. The class or value of the data points that is determined by the majority vote, average k neighbors. Majority vote means maximum number of the neighbors. Okay. This approach allows the algorithm to adapt to different patterns and make predictions based on the local structure of the data. That is what it does. Okay. So, I hope this slide is very important, that tells you everything about the k nearest neighbors, right. So, it is basically based on finding the nearest neighbors, number of nearest neighbors of a given point, and this nearest neighbors are calculated based on the distance matrix, which is nothing but a distance of this point with respect to the neighbors. And in material science, people know about nearest neighbors, like in case of FCC structure you have 12 nearest neighbors, BCC structure you have 8 nearest neighbors. How do you find out? Basically distance, right? So that is how it is find out. Then now if and the class is determined, basically class or value whatever you determined by the majority vote, number of nearest neighbors. Like here this point has more nearest neighbors to the red than the blue, that is why it belongs to the red class. So main idea is that KNN classification rule is to assign a set test sample the majority category level of its k nearest neighbors. So normally in practice you will choose k as negative odd to avoid any ties, and one can have 1, 3, 5, 7, 9, 11 kind of values of k. So k is a variable, that is why it is called k nearest neighbor. So if I have first one nearest neighbor, you can see that is what is correct. So I go back, so I have black and blue, and then I have a unassigned point which it belongs to. So I calculate the first one nearest neighbor. I can clearly see this point will belong to the black, because black is the nearest neighbor for this blue is far away. Now if I consider 3 nearest neighbor, what can happen? Let us look at that. This is the point I want to find nearest neighbors. See, all the 3 nearest neighbors are basically out of the 3, the 2 are belonging to blue and 1 belong to black. I can go back, right? These 2 are blue, this is a black. So the majority nearest neighbors are blue. So therefore this point belongs to blue. But if when I consider 1, this point belongs to black. That is the classification, right? So k has a role to play. Which k will use? That is a difficult decision. Normally it should be as possible. So the mean value of k nearest neighbor samples, basically what is to be used. And I give another example. Let us take class 1 and class 2. The blue is class 1, the green is class 2. I have a target point this. So what I have done here? I am drawing lines, right? You can see that, and finding out the nearest neighbors. So how many nearest neighbors for the green? Blue I have only 3 nearest neighbors. Majority class is 2. That is why it belongs to class 2. So that is very easy to understand. One can also do distance weighted nearest neighbor algorithm also. Distance weighted, remember. In ANN we use weights, right? So you can assign weights to the neighbors based on the distance from the query points to make it complex, more difficult, right? So weights may be inverse square of the distances. Okay, all kinds of things are possible in this world, remember this. So all training points may influence the particular instance then. Okay, I am not talking about that, there is a shepherd method possible. Okay, shepherd methods, shepherds, they take the animals to the outside for grazing, they use certain kind of training methods, that is what is called shepherd methods. So let us not talk about it here. But when you talk about this nearest neighbors, what is important is to Voronoi diagrams, and these diagrams, it shows different Voronoi polyhedras, right? You can see that. Okay, all this is a 5, 4, 3, there no 3, this is also 5, this is also 5. So you can see that this is 4, this is 4, right? This is 5. So different Voronoi polyhedras are shown here in 2D. Now all possible points to the samples Voronoi cells are their nearest neighbors. Obviously for this there is no nearest neighbors. Can you see that? So all possible points within a sample's Voronoi cells are nearest neighbor points for the sample. For any sample, the nearest sample is determined by the closest Voronoi cell edge. Okay, that is what the rule says. Closest Voronoi cell edge. This is the closest Voronoi cell edge for this. This is for this one. This is for this one. That is what is determined. So now there can be different distance matrices possible also. Am I clear? So what you knew is a Euclidean, all of us. So let me explain to you. So Euclidean is what? Euclidean is similarly nothing but distance dxy is sometime like this. So you sum it over I equal to m xi minus yi whole square. What is that? So if I have x1 y1 x2 y2 2 points, I know I take like x2 minus x1 whole square plus y2 minus y1 whole square, that summation is that, summation is sum. Then you can also have Manhattan, okay. It has Manhattan is a city block. So dxy is like this, I 1 to n xi minus yi mod. That is the distance. Another way of calculating distance. You can also have Minkowski, and this is similar but not same, x I y I to the power r, then to the power 1 by r. One can use many types. One of this is given by name of the Indian scientist called Mahalanobis. Okay, he is he establishes the Indian Statistical Institutes, Mahalanobis. Remember, you have a distance by your name, that is so important. So, d x y is derivative of v to the power 1 by m x minus y to the transpose v to the power minus 1, very complex. Okay, v is a covariance matrix, not derivative. Determinant of b is a covariance matrix of a1 to am, and aj is a vector value for the attribute j. Well, they are very complex, but what you can use is chi square. Chi square is a very good one. Chi square is widely used, and it gives you distance like this, I equal to 1 to n, this 1 or sum of 1 I, right, yes, x y x I sum size x y I by size y, size, remember, not sign, size square. Sum I is the sum of all values of all attributes I, and size x is the sum of all values in the vector x. Sum of all values x, x1 plus x2 plus x3 plus x4, everything. Okay, that is what it is. So, you can have all kinds of distance matrix possible. For your safety and for your easiness, better to use Euclidean. That is the easiest one we learned from coordinate geometry from class 10th. So, that is what you should use. And you have to understand also, you have a scale effect, right. Different features may have different measurement scales. So, a patient weight in kg versus blood protein values in nanogram per deciliters. So, that you can see there is a scale effect. So, consequence is that patient weight will have a much greater influence on the distance between the samples. So, that will lead to biasing of the classifier. So, that is all for this KNN. It is a very easy technique, and I hope you can understand it. You will use it a lot for classification. The next lecture onwards we will talk about unsupervised learning. I will start discussing the method known as clustering. Okay, how we can use unsupervised learning for data sets. Thank you.